Good morning dear students, this is Varani Porokasto. I welcome you all to today's video. Today we will start chapter 5, continuity and differentiability. Question number 1 of exercise 5.2. Here the function given is sin x square plus 5. We have to differentiate the function with respect to x. That means we have to find d dx of sin x square plus 5. So first of all, here we will apply the formula of sin x, d dx of sin x. d dx of sin x means cos x. So here we will consider this part as a whole x. So the formula of d dx of sin x will be cos x. Now since here we have considered this part as x, but this is not x, this is x square plus 5. So now we have to again differentiate this part. So d dx of x square plus 5. Now here d dx of x square plus 5 means d dx of x square plus d dx of 5. So we know d dx of 5 is 0. d dx of x square means d dx of x to the power n. The formula is n x to the power n minus 1. So from here we will get 2x. And d dx of 5, which is a constant, so it will be 0. So we have not written the 0. The answer is 2x cos x square plus 5. Question number 2. The function given is cos sin x. Here we will differentiate cos sin x with respect to x. So first of all we will write d dx of cos sin x. Now we will consider this sin s as a whole x. So d dx of cos x means minus sin x. The formula of d dx of cos x is minus sin x. So here we have written minus sin, and in place of x we have written sin x because we have considered sin x as x. Now since we have considered sin x as x, we have to again differentiate this sin x. Now in the next step, d dx of sin x means cos x. So the answer is minus cos x sin x. Question number 3. The function given is sin ax plus b. We have to differentiate sin ax plus b with respect to x. So we will consider this ax plus b as a whole x. So d dx of sin x is cos x. So in place of x we will write ax plus b. Now we have to again differentiate this ax plus b. Now d dx of ax means x because here a is a constant. So d dx of ax, here we can apply the formula of uv. So whenever a is constant, d dx of x is 1, plus whenever x is constant, d dx of a will be 0 because a is a constant here. So from here we will get a. So d dx of ax is a and d dx of b will be 0. So our answer will become a cos ax plus b. Question number 4. The function given is sec tan root over x. So d dx of sec tan root over x, here we will consider this tan root over x as x. So d dx of sec x is sec x tan x. So sec, in place of x we have written tan root over x, and tan, in place of x we have written tan root over x. Since our formula is d dx of sec x is equal to sec x tan x, so we have written this in this way. Now since we have considered this tan root over x as a whole x, we have to again differentiate this tan root over x. For the differentiation of tan root over x, we will consider this root over x as x. So d dx of tan x is sec square x. Now since we have considered this root over x as x, we have to again differentiate this root over x. Now d dx of root over x means d dx of x to the power half. That means here we can use the formula d dx of x to the power n, which is n x to the power n minus 1. See, here we have written half into x to the power minus half as half into x to the power half minus 1. From half minus 1 we will get minus half. So from here we will get sec 10 root over x, 10 root over x, sec square root over x, 1 by 2 root over x. In question number 6, the function given is cos x cube into sin square x to the power 5. Here we have to differentiate the function with respect to x. So for that, here we will use the formula d dx of u v. So the formula is, whenever we will keep u as constant, we will differentiate v, plus whenever we will keep v constant, we will differentiate u. Here we have kept this cos x cube as constant and we will differentiate this sin square x to the power 5. Plus here we will keep this sin square x to the power 5 constant and we will differentiate cos x cube. Here we will consider sin x to the power 5 as x. So whenever we will put a square, it will become x square. So from here we will get sin square x to the power 5 is x square. Now if we use the formula of x to the power n, then it will become n x to the power n minus 1. So from here we will get 2x. In place of x we can write sin x to the power 5. So see, here we have written 2x and in place of x means sin x to the power 5. Now since we have considered sin x to the power 5 as x, we have to again differentiate this sin x to the power 5. And here we will consider this x cube as x. So d dx of cos x will be minus sin x and in place of x we will write x cube, d dx of x cube. Now from here we will get sin x to the power 5 means we will consider this x to the power 5 as x. So d dx of sin x will be cos x and in place of x we will write x to the power 5. Again we have to differentiate x to the power 5 and from here after differentiating we will get 3x square. Now in the next step we will get from here 5x to the power 4 and it will remain same. So our answer will become 10x to the power 4 cos x cube cos x to the power 5 sin x to the power 5 minus 3x square sin x cube sin square x to the power 5. Question number 7 of exercise 5.2. Here the function given is 2 root over cot x square. So we have to differentiate this with respect to x. Here we will use the formula of u v. First of all we will keep 2 outside and we will differentiate this root over cot x square. Plus if we write root over cot x square and if we differentiate 2, then this part will become 0 as 2 is a constant. Now we have to differentiate root over cot x square. So first of all we will consider this cot x square as x. So it will become root over x. So d dx of root over x means 1 by 2 root over x. So here we have written 1 by 2 root over cot x square. Now, so here we have to again differentiate cot x square, since in this part we have completed the work of this root. Now we will do the work of this cot x square. For differentiating cot x square, we have to consider x square as x. So, ddx of cot x means minus cos x square x. So, in place of ddx of cot x square, we will write minus cos x square s. We have x square in place of x. Now, we have to again differentiate x square. So, from here we will get 2x. Now, 1 by root over cot x square can be written as one by root over cos x square by sin x square. Now, from here we can write it like this. We will get 1 by sin x square into root over sin x square, and this root over cos x square will remain same. Now, if we combine these two, from here we can use the formula 2 sin x cos x. So, since we have multiplied it by 2, that means in this part, in the denominator part, we have multiplied it by root over 2. So, in the numerator also we have to write root over 2. So, from here we can write it as sin 2x square, as sin 2x is 2 sin x cos x. In place of x, if we write x square, then the formula will become like this, sin 2x square. This is the answer of question number 7.